Problem solving with trigonometry. In this section, we'll consider practical applications of trigonometry. This allows us to find heights and distances which are very difficult or even impossible to measure correctly. So the first key thing here we gotta know is the angle of elevation, angle of depression. As you can see here, angle of elevation is the angle that goes up, angle of depression, angle that goes down. The key part of this that a lot of people skip is this is coming from a horizontal line. So anytime I hear angle of elevation or depression, I draw a horizontal line. The angle going up is elevation. Angle going down is depression. The horizontal line is the key. So you need to draw that horizontal line first. And then it's above that line to elevation, below that line is depression. So you can see that down here, horizontal line, angle of elevation, horizontal line, angle of elevation, angle of depression. So this is an example. A tree casts a shadow of 12.4 meters when the angle of elevation is to the sun is 52 degrees. Find the height of the tree. So we have a tree. Now let's draw a horizontal line. Now remember what's going on here is that find the height of the tree. That's this. Then cast a shadow. So the shadow we're going to say is going this way. So there's a sun back here. It's cast shadow going this way. So we have a point there. Oh, that's a bad angle. It's not something to that effect. And now remember, it's our angle of elevation. So here's our horizontal line. So angle above that would be the angle we're looking for. Actually, that would be the angle of 52 degrees. They tell us what that angle is. That's 52 degrees. A tree has a shadow 12.4 meters high. So this shadow here, that's what this part is. It's a shadow. Is 12.4 meters. So all we have here is a triangle. This is a right triangle because it's the height of a tree. And all we have to do is figure out how to solve this. So we'll set up here's our angle. Figure out the sides. This is opposite. This is adjacent. So O and A should be TOA. So tan of 52 degrees equals x over 12.4. Now we're just trying to solve for x. So let's just get rid of the 12.4. Apply both sides by that. And we get 12.4 times tan of 52 degrees equals x. Now let's use that on my calculator because it is an application problem. Usually the application problem we actually want the answer. 12.4 times tan of 52 degrees. And it was 12.4 times tan of 52 degrees. And 15.87. So 315.9 meters. And that's our first example. So we draw it, we make a triangle. Solve it like we know how to solve triangles. Next one, the builder has designed the roof structure illustrated. Find the pitch of the roof. Now the pitch is this guy. The angle right there. So that's what we're looking for. Now look what's going on. We have we have a house down here. It's 13 meters wide. We have 1 meter on each side. We have a roof that's about 8.7. So if we want to find that pitch, we probably want to make a right triangle. Something like that. Let me recreate it down here so we have something to gauge it off of. This is the status I'm looking for. This is the 8.7. Now this whole base here is 13, but if you add the little sides, this whole thing is 15. But right, our thing, we're only doing half of it, so we're doing this half plus that half, which should be 15 divided by 2 or 7.5. Or you guys think about it as this is like 6.5, it's half of 13. But don't forget to add the little overhang of 1 meter. So we have this, and all we're trying to do is find the angle. So, list your sides in your head. This would be opposite. This would be a hypotenuse. Just put the right angle there. Remember when you bisect this side, it makes a right angle. And then this makes adjacent. So we have O and A and H, that's cosine. Cosine of my angle equals 7.5 over 8.7. Then we have to solve for cosine, so let's take the cosine inverse of both sides. We have to solve for the angle. Let's take the cosine inverse of both sides. So that equals that, and then I need a calculator again. So remember the way we do this is inverse cosine. So second cosine, 7.5 divided by 8.7, which is 30.5-ish. So there's the angle of the pitch. Next one, a rectangular prism has a dimension shown. Find the measure of ABC. So first thing, when they say ABC, B is the middle angle there. So I'm gonna make a triangle and we're gonna highlight B. So we want to find out. Let's do dark blue. ABC. So from B to A, and then from B to C, and then from C to A. Close enough. So that's our triangle. Now it's kind of hard to see, but this will be a right angle. You can see that triangle there is kind of like slanted down, right? B and C, then it connects to that A. That is a right triangle because this right here is a straight line, like a right triangle. This thing like perfectly bisects this side, so it makes it a right triangle. So we have that, and we want to find the measure of angle B. So we were looking for this guy. So I know what one. So like if we just repurpose that triangle just so we could see it, like not slightly three-dimensional. It looks like this. Where this is the x we're looking for, and we know this bottom side here is 14. Right, we're missing one more thing. We need one more thing to solve this. Well, look right here. Like I said before, this perfectly cuts it in half, even though my drawing's a little off. This is a right angle. If you just get this triangle here, we have a triangle that has a right angle, 11 and 6, and we need the hypotenuse, because that hypotenuse is the exact same side as this one. Right, these are it's a hypotenuse for this triangle, but for this big triangle, it's just the tall side. So we gotta find an h. So we're gonna do a squared b squared c squared, a squared plus b squared equals c squared. Where again, the only thing that matters is c derivative hypotenuse. So we're gonna have 11 squared plus 6 squared equals c squared. So I get 121 plus 36 equals c squared. So I get 157 equals c squared. So I'll square root of that. So that's what c is. Or I should say that's what my height is. Radical 157. And then the question was to find the measure of angle ABC, which is right there. So now you just list up your sides in your head, like this is opposite. This is adjacent. Because it's hypotenuse. Opposite of 90, right? But all we have is opposite and adjacent. So gatoa. So cosine of x equals adjacent over opposite. And then we're going to do cosine inverse of both sides. And I go type that back into my calculator because I don't know what that is. So we're going to go cosine inverse again. 14 divided by square root of 157. We got 71.4. So there's that one. So that's how I figure out what angle B is. Right? I have to figure out the side of the triangle R. And then since it's a right triangle, I can use SOHCAHTOA to figure out what the angle was, which I did down here. Next, the angle of pressure on the top of a 15-meter high cliff to a boat at sea is 2.7. How much closer to the cliff must the boat move to an angle of depression to become 4? Okay, let's draw some pictures here. This is my ocean, by the way. It's near a horizontal line in case I need it. This is 15 meters high, and then we're going to go to a boat. And it says my angle of depression is 2.7 is the first one. Okay, so remember angle of depression from the top of the cliffs we're talking about here. Now the key thing here is you draw a horizontal line, right? Because a lot of people they'll put 2.7 right here, and that's wrong. Remember, it has to come from a horizontal line. Angle, elevation, depression, you always draw a horizontal line first. And then it's the angle below that's depression. So this is 2.7. Now, what happens is we want to see how much closer to the boat has to move to make the angle of depression 4. So let's, in blue, I'm going to draw the same boat over here. Draw another angle, but this one to this boat. And again, notice how, so angle of depression is like this guy. So I want this to be 4. So what we're going to do here is figure out what this length is. Figure out what this length is. And then subtract them to figure out how far it has to move to get to a 4-degree angle of depression. So that's the idea. So we have two triangles here. Right, we have the small triangle. That's 15, 4, and x. And then we have the slightly bigger triangle. That's 15, 2.7, and y. And this, so in both of these should be degrees. Right, so we gotta solve it. So opposite, my right angle, so this is adjacent, so that's a tan. Same thing here. So we're gonna have tan of 4 degrees equals x over 15. So x would equal tan times 4, tan of 4 degrees times 15. And then we're gonna have tan of 2.7 equals y over 15. So 15 times tan of 2.7 equals y. So put those on my calculator. Oops. So let's go. Tan 4, remember always in degrees. Well, now we are. Then I get about 1.05. And then let's do the other one. Is that 15 times tan of 2.7? 0.777. Let's subtract these. Alright, so how many meters does the move to get equals minus this one? And there we go. About 0.342 meters. Let's move a little bit to get to that angle. So about that many meters. And it's application problem, so say like the ship, the boat, must move 3.42 meters to get the angle of pressure to be 4 degrees. Okay, last one. Elizabeth is terrified of spiders when she walks into the room, so she notices one on the opposite corner. If Elizabeth is 1.6 meters tall, how far is the spider from her head? So she is 1.6 meters tall. The spider is in this corner. And how far is it from her head? So if we draw a straight line to her head, right? Yeah, I guess we were supposed to go up to this triangle and then go all the way back to her head. So that we're trying to figure out this distance here. Right, here's our right angle. Now this is 2.3, the whole height. We know she's 1.6, we gotta subtract and get 2.3 minus 1.6 is 0.7. Now this diagonal here, we can figure out because we have the two sides of a triangle. So the top, look at the top face down. Right, this is 5.6, this is 8.5, like this is S, this is her head, all hat. We're trying to find this guy, right, because that's going to give us this value right there, which will help us get this value. And no angle, so we're just going to do Pythagorean theorem a lot. So 5.6, remember A, B, and C's hypotenuse, one part that matters, equals C squared. Let's use a calculator. No messing around. So 8.5 squared plus 5.6 squared. It's me 103.61 equals C squared. Square root both sides. So about 10.2 for doing 366. So no, that's not my answer. So 10.2. No matter, that just helps us get, oops, sorry, can't see where I wrote it. That just helps us get to this part, because that's this guy. So now I can figure out what the height is, or how the distance from our head is. So now we have another triangle, where this is 0.7, this is 10.2, and this is what we're looking for. So Pythagorean theorem again. Again, not going to mess with this and put in my calculator. So 0.7 squared plus, let's just use this answer from here. Right? Again, if the question was like first figure out this, then I would just use 10.2. But since that's not the question is x, I'm gonna solve that. And square root that. And we get this. So what did I get? 104 is approximately x squared, and then square root that. And x is approximately 10.2. So 10.2 meters from her from woman. So that's A. How far is the spider from head? It's about 10.2 meters from her head. If the spider can see an angle of 42 degrees from the direction it's facing, this spider is facing the fly at F. So it's over here, it's facing the fly. Can it see Elizabeth? So let's look at this let's copy down this top-down picture again. Alright, so here's Elizabeth. We notice it's 5.6, we notice it's 8.5, and we got this thing over here we had, which we figured out was 10.2-ish. Now the question is, the spider's facing the fly right there. The question is this 42 or not? That's the whole game here, right? If that's less than 42, she can't see. The spider can't see Elizabeth. If it's more than 42, Elizabeth is dead right. So we're just going to figure out that angle. So we have a right triangle. We have this side right here, which is adjacent. And we have this side right here, which is opposite. I like to use the given values anytime I'm trying to solve for an angle instead of the one I found, because it's going to be a little off if we rounded it. So I just try to use the given values. So we have opposite adjacent, so we're trying to figure out what this is. So it's tan. Tan of theta equals opposite TOA over adjacent. So to get rid of tan, we're going to take tan inverse. These cancel, I get theta is equal to tan inverse of 8.5 or blah blah blah. So let's do tan inverse of 8.5 divided by 5.6. Like about 56 degrees. So it can't see it, right? The spider coordinates say an angle 42 degrees. And we're at 56, so Liz is safe. Nope. Can't see him. That's it.